Okay, and there is the test question. It says, or not a test question, a homework question. It says the graph to the right is uniform density function for a friend who is X minutes late. Find the probability that the friend is at least 24 minutes late. Now, I don't agree with this question because when you say at least, that means your lowest number is 24. Okay? And you can get confused thinking that way with at least 24 minutes late. Because technically, if you're late, that's at most. You see what I'm saying? If you're late 10 minutes, and that means you're late 10 minutes after the fact. That would be 10 more minutes because you're late. So it can be confusing. So what I tell students is, and I'll just leave this, and this is for the video. The question was asked before class. The question was asked, what is the difference between binomial and normal? Binomial is when you're given in the question N and P, N and P, and then they ask for the probability of X. Now also, a lot of people say, well, how do you know when to use NPQ? Well, NPQ is equal to the mean, the NP is equal to the mean, and the square root of NPQ is equal to what? Standard deviation. These questions will say, find the mean and the standard deviation. So, you know, the directions here will say, find the probability. The directions here will say, find the mean or the standard deviation. And these right here will say, find the area under the curve at the z-score. So your directions will tell you what to do in chapter 7 or 6. And once you, like I told you before, in probability and statistics, it's not that you can do the math, it's that you can read the directions and read the question. So directions will say find the probability. Directions will say find the mean or the standard deviations. Directions will say find the area or find the z-score. It'll say either one. If it says find the area, then you use inverse norm. Let's see. Find the z-score for the area, you use inverse norm. If you have to find the z-score given the area, then you use inverse norm. If it says find the area given the z-score, you use normal CDF. Okay, here's the question that was sent in the homework. This is the only question I got. And it is uniform distribution. The base is from 0 to 30. Therefore, the height is equal to 1 over 30. And they say, what is the probability that your friend is at least 24 minutes late? Well, this is 15. Halfway between 0 and 15 is 7. Halfway between 15 and 30 is 7. So that would be what? 23 or something like that? So they say 24, so I'm going to put 24 right about there. Now, it says at least 24, right? So that means the lowest number is what? 24. At least 24 means the lowest number is 24. So therefore, they're looking for the area to the left or to the right?
To the right.
To the right. So what's the base of that box? Well, from 24 to 30 is what? 6. So the area at 24 is equal to 6 over 1 times 1 over 30, which is 6 over 30 which is 1 over 5, which is 0.2, which is 2 over 10, which is equal to 0.2. And that's how you do that problem. Okay? Is that a test question? Yes. Out of the Chapter 7 material, if I give you 10 questions, 2 of them will be like this. So make sure you can do at least 2 of these. All right, let's look at the test. All right, so we go to the handy dandy, make sure. I don't see another, nope. Let me do it by date just to make sure. Date. Nope. Oh, there's one right there. I'm glad I did it by the date. There's another one. I don't know if I did that one. Or is that the one I just did? 7.115/6. Let's see, that's the one I just did. Yeah, that's the same one. All right, so that takes care of that. And I think I did this one last week. 7.27/3. I think I did this one Friday or Wednesday or Thursday. I can't remember. Yeah, I did this one because there was 4. There's 4 test questions right there. 1, 2, 3, 4. And if you look, I think I did this one Friday. I'm pretty sure because I drew 4 curves on one sheet of paper. All right, so let's move on to the test. And there it is. And the date is 4/6 to 4/13. Preview. What kind of lag we got? Is there a long lag?
Not how it usually is.
Wait a minute, that's the wrong test. I gotta go to 120. Sorry, guys. All right, 120. I got the Corona. That's what it is. Isn't it amazing how the flu just disappeared? Nobody even talks about the flu. Anyway. Where's 120/23? 120/23. There y'all are. And I think y'all's test is already up. If I'm not mistaken, I believe it is. And it should be called Unit 3 test. Should be covering 6 and 7. There it is, Hubert's Unit 3 test. Due on the 6th. Today? That's not right. Is it due today?
I think you said you were going to back it up to Wednesday.
Okay, thank you. All right, so let's go to preview. I'll fix it after class. All right, so here we go. I'm going to skip the bonus questions. Y'all can answer the bonus questions. All right, so here's our first question. Assume that the random variable is normally distributed with a mean of 66. Draw the curve. So we know this question, draw the curve. So I'm going to draw my handy dandy. I'm not going to even look any further because I'm going to draw the curve. Zero, 1, 2, 3, -1, -2, -3, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. All right, so now I've done what the first part of the sentence. It says compute the probability of being between 55 and 70. Oh, I forgot to do the 66. All right, 66 and 14. So I'm going to do that in blue. 66. 66 plus 14 is what? 80? 80 plus 14 is 94. 94 plus 14 is what? 108? Y'all help me out there, because I suck at adding and subtracting in my head. All right? What is 66 minus 14? Dang old 52. What is 52 minus 14? 38? Y'all gonna have to help me here. 38 minus
right.
14 is 24. All right, check my numbers. Those numbers correct? I depend on Miss, yeah, okay, Miss Carver, she stays up with everything. Miss Colbert, she don't say anything. She just watches. She don't ever say anything. All right. So, what does it say? It says find the area between 55 and 70. So I'm going to take my handy dandy yellow marker so y'all can bitch. And I'm going to put a 55 right in here. Let's see. What's between half of 14 is what? 7. So that'd be a 59 right there. And they want 55. So 52 to 59 is 7. Half of 7 is 3.5. That'd be 55.5. So halfway here, which would be negative 0.75, somewhere around there. Okay? No, that's not going to work. Y'all can't see that, so I'll do it in green. Negative 0.75-ish. Now, what am I doing? I'm using the empirical rule because I want to know what the answer is before I start. Okay? So, the other number is 70. Well, 60, this would be 73 right here. Because half of 14 is 7. So that'd be, 73. They said they want 70. So 66 to 70. If I take 73 and I minus 7, or 66 plus 7 would be what? Well, I mean, 3 would be 69 to 70-ish. 70-ish is right in here. So they want to know this area. Well, I think I used about a fourth here. So a fourth, 34, that's 8. So 8, and that makes this 3 times 8, which means that's about 24-ish right there. And then 1 times 8 is 8. So 8, I'd say around 0.3200 is about what I come up with the empirical rule. Okay? So I think the answer is going to be around 0.3200. Now, if you have an old calculator, you're going to have to change this number, which is 55, into a z-score. 55 minus 66 divided by 14, which is equal to 11 over 14. Somebody give me 11 over 14 in a z-score, please. 2 digits. What's 11 divided by 14? It's going to be negative. What do you get? 0.79. Thank you, Miss Carver. I said 0.75-ish, so I'm close. And then 55 or 70 would be 70 minus 66 over 14, which is 4 over 14, which I said is going to be around 0.25. 0.25-ish is what I think. Somebody take 4 over 14 and give me 2 digits. And I'll wait for Miss Carver because nobody else will say anything. So 4 divided by 14. Thank you, Miss Carver. I said 0.25. So take your handy dandy calculators and go from negative 0.79 to 0.29 if you got an old calculator. If you got a new calculator, then you just go from 55 to 70. So I'm going to take my calculator, since it's aggravating to work. I'm going to do with a mouse. This is when you use normal CDF. Second, bars, normal CDF. And I'm going to go from negative 0.79 and upper is 0.29. That is if I have an old calculator. If I have a new calculator, I would put 55, 70, 66, and 14, and then let it do its thing. So if you've got a newer calculator, tell me if you got the same as I got. I got 0.3993. What did y'all get? Okay, I'll wait for Miss Carver because nobody else will say anything. 0.3964. Okay. I don't know why you got a different number, but that's fine. I don't know why it would be that much different. It shouldn't be. Okay. What I would suggest, maybe Miss Carver, is maybe take your z-score to 4 digits. What did you get for 55 minus 6, 11 over 14? Tell me what you got for 11 over 14. You might want to take it to 4 digits. You got what did you get, Miss Carver? .7857. 0.7857. All right, I want you to use that for your lower. And what did you get for 4 over 14? Y'all know we wouldn't have to wait as long if y'all talked. Y'all know that, don't you? 2857. 0.2857. Now, Miss Colvishon, Miss Carver, since you have an older calculator, use those two 4-digit numbers and see if you get the same thing I got. 0.3993. See what you got. What did y'all get, Mr. Brooks and Mr. Colvishon? Miss Colvishon, what did y'all get? Did y'all get the same thing?
I was way off, but I'm looking back to see what I did wrong here.
Okay, do you have a newer calculator or older calculator?
It's a newer one. It'll do both the upper and the lower split.
Miss Carver, what did you get? Did you got it typed in yet? Should be 0.3993. Let me see what the test says. They might have a variance in the answer to where y'all could punch in several different answers. 0.3993. 0.3993. Okay, well I must be wrong. And which one is it? It should be this one. I got it right, but there may be a variance in there of 2 or 3 hundredths or thousandths. So if you get it wrong, Miss Carver, just see me or somebody see me, and I'll be glad to make it good. All right, because you should be close. All right, next. Most of your Chapter 7 questions will be like that one. I'm not going to cover this one because we just did that one. Okay? What is the base between 20 and 30 minutes? 10, Hubert. Thank you. Thank you, Miss Carver. So that'd be 10 over 30, which is 1 over 3, which is 0.33. It is 10 a.m. There is a 10% probability that the friend will arrive within how many minutes? It's 10 a.m., 10% probability, so that means 10 is going to be equal to, now I'm not used to that one, so I'll show you that one. Okay, so the first one, y'all should be able to do the first one. Just draw your, and we got 0 to 30, 0 to 30. That means that this height is equal to 1 over 30. And they want to know between 20 and 30. So 20 and 30 is 10. So 10 times 1 over 30 is equal to 10 over 30, which is equal to 1/3, which is equal to 0.33 repeating. All right, so that's the first part. The second part will be 10 is equal to, or 0.10, sorry, not 10, because it can't be above 1. 0.10 is equal to base times 1 over 30. Okay, so that's going to be divided by 1 over 30, divided by 1 over 30, which means you're going to multiply by 30. So what's 10% of 30? So 3 minutes. So first one is round to 3 decimal places, 0.333. And this one, 3 minutes. And you should feel good about yourself. Next. All right. In the probability distribution to the right here, X represents the number of hits a baseball player obtains a game over the course of season. A through F, really? I didn't mean for this one to be on here. Verify that there is a discrete probability. You either hit the ball or you don't hit the ball. So there's a 50-50 shot. Is there a fixed number of trials? Yes. 0, 1, 2, 3, 4, 5. Boom, that's it. And the probabilities are between 0 and 1. There's no negatives, and you might want to add those up, but they should equal 1. All right? At least one of the probabilities, all the probabilities are between 0 and 1, inclusive, and the product of all the probabilities is 1. So you need to look at those and tell me, make sure that they're all, well, let's just take it over here. Open it in Excel. I think they're going to want mean and standard deviation, so we'll go ahead and do all that. Okay, where's my... I'm just going to do whatever I know to do, and then we'll decide what's after that, after we look at what I've done. If it ever comes up, we'll make it bigger for y'all. There you go. And we're going to make these a little bit wider and make these a little bit deeper, and make sure that y'all can see the grids around them real good. And let's make that top row, let's make all of it centered. I'm OCD about that. And top row, make that bold and underline. All right, so you want to draw it, insert. I do a chart plot because it's a whole lot easier. So I need y'all to sketch this out. That's what it looks like. Sketch it out because I'm going to delete that here in a second. So I'm going to draw my sketch. It looks got a hump at the left, and then it looks like it kind of dwindles out. Looks like it's skewed right because all the data is on the left. So it's a little bit skewed right. Okay? I'm going to delete this. So now let's find the mean. What is the mean? The mean is the summation of x times what? X times p of x. This times this, and copy that down and add that up, and that's our mean. So write that down as your mean. What the heck? Oh, you know what? I think I'm about ready to quit. There. So our mean, I'm going to write that down, is equal to 1.6265. And let's figure our standard deviation, because our variance, I'm going to write down the formula, is equal to the summation of x squared times p of x minus the mean squared. Minus the mean squared. So I got to take x squared, and I have no idea if they're asking this or not, but I have a feeling they are. So x squared is equal to this raised to the second power, and I'm going to copy that down, and then I'm going to put over here x squared times p of x. So that's equal to 0 times p of x, and I'm going to copy that down, and that's going to be my summation. And now I'm going to subtract, so I'm going to put mean right here. Mean, variance. My variance is going to be equal to that number minus the mean squared. So equals this number minus parentheses mean raised to the second power. And that's your variance, and the standard deviation is the square root of that. So that's going to equal this number raised to the 0.5 power. Okay, so our variance is equal to 0.7785, and our standard deviation is equal to 0.8823. Now, that's all I can add, that's all I can figure they're going to ask. So let's go back. Draw a graph. We said is a little bit skewed right, so it looks like that one. The mean is equal to, it says type an integer, do not round. So I got 2. 1.6 is, okay, 1.6. Which of the following interpretation of the mean is correct? In any number of games, one would expect the mean number of hits to be the mean of the random variable. Over the course of many games, one would expect the mean number of hits per game to be the mean of the random variable. The observed number of hits per game will be equal to the mean number. The observed number of hits per game will be less than, I think it's either A or B. I would say B, but it could be either one. I think it's B. We'll see here in a minute. It says round to 3 decimal places. That's 0.882. What is the probability 2 hits? That would be 0.2869. What is the probability got more than 1 hit? Well, 1 hit would be this, and you'd add these 3 up right here. I'd add these 4. So I'm just going to add these 2 and take the the complement. So that's going to be 0.49. Okay. Let's see. 7 and 1 is 8. 7 and 5 is what? 12. Bring you 1. 6 and 3 is 9. That'd be 0. Bring you 1. 3 and 1 is 4.5. So 1 minus 0.5 would be 0.4862. I think it's 0.4862. Because I just took the complement. I took 1 and 0 and added those up and subtracted it from 1. And I got 0.4862. And that should be your answer. Why isn't it asking me to check answer? Did I not answer everything? It's supposed to let me check the answer. Oh well, next. Okay, somebody tell me what I hadn't completed. Oh, right here. Multimodal is uniform. It's not uniform. It's not multimodal. Has one mode and is bimodal. I don't see a mode. No. Two games. I don't see. Skewed right, but I don't know. Somebody tell me what the answer here, because I don't know what they're asking. It don't look like it has any. Y'all seen this in the homework? It's not uniform. I guess you'd say multimodal. Don't have a. I don't know.
It only has one mode, I think.
What?
It only has one mode.
I don't even see them.
It should be X is equal to 1. That should be its one mode, right?
Yeah. Let's just see where I messed up. I don't like A through F questions. All right, let's see what I got wrong. Looks like I got everything right. So what did I get wrong? Oh, here's Okay, they got 1.7175 standard deviation. So y'all check my math. I don't know. I must have done something wrong. Is that the only thing I got wrong? .175. So let's go back and let's see what I did wrong on the mode. I meant the standard deviation, or the mean. Wait a minute. Did I get the mean wrong, or what did I get wrong? They said the standard deviation is 1.175. I don't know how you get 1.175 from the variance. Let me make sure I got that right. Oh, okay. Okay. The sum of this minus this raised to the second power. I don't know how I got that wrong. Does somebody, let me check it. Equals this number minus parentheses this number raised to the second power. Okay, I must have hit something wrong. I don't know what I hit wrong. I'm sorry. Okay, my bad. Let me move on. Next. Okay, this is NPX. Okay, this is your question, Miss Carver. This is the one that you asked about. This will be binomial CDF for cumulative. Draw your number line. 0, 1, 2, 3, 4, 5, 6. What is less than 4? Zero, 1, 2, what? 3. There's no decimals because these are like households. Is there such thing as 1.5 households? No. So this would be cumulative because they want to know everything up to 3. Because you can't use 4 because it's not equal to. So this would be second, bars, binomial, CDF because it's cumulative. Adding all to the left. Adding all to the left. CDF of 3. Okay, so you would type in NPX or binomial CDF, and that would be N is 6.45 and 3. And somebody give me that number to 4 digits. Should be 0.7447. Y'all check and see. Of course, Miss Carver, I'll wait on you to respond. I can pull it up right quick. Second, bars, binomial, CDF, enter. Trials is 6. P is 0.45. And X value is 3. Now, if you have an older calculator, you would just set binomial CDF and you would hit 6, comma, 0.45, comma, 3, close parentheses. And there's several of these on the test. Give you a few points. They're not that difficult. Now, what if it said exactly 3 or exactly 4? Then you would be using PDF, which means precise, and you would just do 4. And it would just mean at 4. Oh, me. Determine the area under the standard normal curve that lies between the following values. Okay, that's pretty straightforward. You don't have to calculate anything. You just 1 and 3. So, Mr. Carver, I think you have an older calculator. This is the kind of question you would want. 1 and 3. You just lower bound 1, upper bound 3. That's it. I'm not going to go over that one. And I'm probably going to extend this till Friday. Yeah, let's go ahead and stop for right now, and I'll extend it till Friday because we need to go over this one. Okay? All right, so I'm going to stop right now, and I'm going to get out of this. I'm going to extend till Friday. Settings for class. When is the homework due? Somebody tell me.
I think it was due today.
Okay, I'll make it Wednesday. So there's that. Let me go to the homework right quick while you're here. And I'm going to keep the video running so that way students will know. Although I don't think some of them are watching the videos. They send me emails. And the emails are like stuff I go over in class. Of course, I don't respond because they ain't watching the emails. They ain't watching the videos. Not a dang if I'm going to repeat myself. All right, 7172. Yeah, 6th. So I'll change that. Six one, 6-2, 7-1, 7-2. Let's change that to Wednesday. You know what? Y'all are blessed, I tell you. That'd be the 8th. How's that? That feel better? Okay, so your test is due Friday. Your homework is due Wednesday. And I will finish going over the test Wednesday. Capiche? All right, y'all have a good day, and I'll see y'all Wednesday.